Welcome to clickmyproject.com. Our product title is Demand Response on Smart Grid. Let us see about the abstract of our product. In this proposed implementation is based on grid connected DC to DC switching converter that is usually connected between the PV modules and the inverter. These PV converters are controlled by improved designing procedure of sliding mode controller, which drives the PV voltage to follow a reference provided by an external MPPT algorithm by provided considering that the switching surface is the linear combination of the input capacitor current and the PV voltage error. The proposed design exhibits advantages in comparison with existing solutions that rely in the linearization of inner current loop dynamics. The proposed power and frequency characteristics of the hybrid unit and of the microgrid operating conditions so that the hybrid unit may supply the maximum PV power, match the load and or charge the battery while maintaining the power balance in the microgrid and respecting the battery state of charge limits. These features are achieved without relying on a central management system on communication as most of the existing algorithms do. The control strategy is implemented using multi-loop controller which provides smooth and autonomous transition between the operating scenarios, and this proposed implementation is done in MATLAB simulating environment. Next we see about the flow diagram of our process. This is our flow diagram. In this flow diagram, this is the input source, this is the input source. Input source is a PV array. PV array consists of number of PV cells is connected in series. After that the solar irradiance is given into the source of the PV array. In that, solar energy is converted into electrical energy using a photovoltaic system. After that electrical energy is fed into DC to DC converter. Here the DC to DC converter switches, IGBT switches, is triggered by using of sliding mode controller. Here the PV voltage and current is fed into the MPPT technique. Here any kind of algorithm is used. Here we using P&O and incremental conductance algorithm. So output of the duty ratio is fed into sliding mode controller. In the sliding mode controller, the output of the DC to DC converter is also considered as the reference, and also the PV voltage is considered, and also the PV voltage error is considered as the reference. So finally the controller generate the pulses of DC to DC converter. Then the DC to DC converter boosting the voltage level from the solar output to DC converter output. Then that voltage is fed into the inverter circuit. Then that inverter circuit is converted to DC to AC conversion. So in the inverter consists 3 legs, each leg having 2 switches, and totally 6 power electronic switches is connected in the inverter circuit. So those switches is triggered using of the inverter control. In the inverter control having the space vector pulse width modulation technique based controller. So here generate the PWM generator generate the pulses for inverters power electronic switches. After that supply is fit into the power grid. In between the grid and source connecting two loads, load 1 and load 2. Those loads are connecting a circuit breaker. That circuit breaker is disconnect which load is enabled in the conditions. Next we see about the running process of our process. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB window and create a new model file. After creating the new model file, we are arranging the elements as per the circuit diagram from the simulating library browser. In the simulating library browser, various blocks are available. Our record block is sim power system and commonly used blocks. So from those blocks we getting the elements and that arranging the circuit as per the base paper. After arranging that, we click the run icon. The corresponding scope will be shown the corresponding output of voltage, current and such parameters. So first one we see the IV curve. This curve is drawn between current and voltage in the solar output, and this is the PV curve. This curve is drawn between solar power and voltage, and next one is the output voltage and current is getting from the solar panel, and next one we see the power of the solar panel. So this range is around 250 watts, and the next one is the circuit breaker on and off relay conditions. So the high position means the circuit breaker is on, the zero when the circuit breaker will turn off. Next one is the DC to DC converter. So in the solar panel the output voltage is 44 volt, then that voltage will be boosted into 53, and next is the inverter output voltage and current waveform. So the DC to DC converter boosted voltage is fed to inverter circuit. In the inverter is convert the DC to AC, that voltage is much level, and next one the output grid voltage and current waveform. So those waveform is zoom. So the topmost waveform is the voltage waveform, and the below waveform is the current waveform. So overall load circuits will be disconnect through the using of the circuit breaker and relay conditions in the function files. So overall efficiency will be increased using of the controlling parameters using in the space vector pulse width modulation in the inverter circuit, and also the sliding mode controller used in the DC to DC conversion. Thank you for watching this video.